This is the Amp Hour Podcast, released December 10th, 2017. Episode 371. An interview with Joe Bamberg. Welcome to the Amp Hour. I'm Chris Gamble of Contextual Electronics.
I'm Joe Bamberg from Sense.
Hey, Joe. How you doing?
Good. How you doing, Chris?
Good. I'm excited to talk to you, mostly because, so I always love having guests onto the show where there's something me and Dave have been talking about for a long time with really no reference point and no knowledge. And in this case, I would think anytime we talk about power, you will be able to kind of clarify all of the crap that we spout about power and unknowingly. Does that?
Yeah, hopefully.
Can you set us straight here? That would be...
Sure.
Okay, obviously Dave's not here, but I will now be in a position of power, and I will be like, no, well, Joe said.
Yeah, you can you can put him in his place now.
Yeah, exactly. So you've been in the power realm, but in kind of a weird spot of it, right? I mean, so you're using tiny little electronics to measure and control lots of, like large wall power. I always say wall power. I know that's not the right term, but AC 120, 240, whatever, right?
Yeah.
So how did you get to that point? Obviously, I want to hear about Sense. Sense is well, you could tell us about Sense, but how did you get to where you are now? Kind of starting back from the beginning.
Let's see. So I studied at the University of Miami.
Okay.
And I was actually a biology chemistry major.
Really?
And
okay.
Pre-med.
Mm-hmm.
And I was kind of I didn't know what I wanted to do. I was thinking medical school, and I kind of got not disillusioned, but depressed at like biology and chemistry.
Disenfranchised at the very least.
Yeah, disenfranchised. That's the word I was looking for.
Yeah.
That you have to. There's just so much memorization,
Mm-hmm.
and I wanted to be able to understand some very fundamental things and be able to figure stuff out.
Mm-hmm.
And my suite mate was a computer engineer, and he said you should look into engineering. So I did. Electrical looked the most interesting because it's so broad, from communications to robotics to electronics. There's so much to it.
Mm-hmm.
And I said I'll go with that, but I maintained my my pre-med. I graduated.
Oh, really? Okay.
Yeah, I took the MCATs.
Oh, wow.
Got talked out of going to medical school by a buddy's dad who was a doctor.
Yep.
And instead got my master's. And after that, I started at Analog Devices, where I had an internship there. And it turns out I grew up in a small town north of Boston called Wilmington. Mm-hmm. And I went to Miami for college and ended up getting a job right back in Wilmington.
Right. You're like, I'm free of the snow. Crap.
Yeah. Well, unfortunately, there's only a couple of places, or big places, to work in tech in the country. And Boston is one. Yep. Like Silicon Valley is one.
Yep.
Like
I
Texas.
was gonna say I would refute that a little bit. I mean, obviously, I was in Cleveland for a long time, but I think there's pockets elsewhere. But it depends. I think it's very industry dependent. So if you want to work in Silicon, for sure, there's 4. I mean, that's why I left Silicon in the first place, is because there's only so many spots to go.
Oh yeah, absolutely. That's one of the reasons I got out of it as well.
I mean, if you start working for ADI, you can always go to Limerick, right? I mean,
that's true. Yeah. I went to Limerick a bunch. Too.
Really?
That's a fun little town.
I've always wanted to go over there. Did it start over there? I don't actually know the tie-in, why Limerick is so prominent for ADI.
The funny story about that was back in the 80s, the Irish government wanted to increase industry and business over there, so mm-hmm. they set up some very advantageous tax rules.
Just that's why Apple's headquartered over there, quote unquote, right?
Yeah. So it was pure back in the 80s. It was purely at least from what I understand of the ADI history, it was purely a tax play to be over there, and it kind of grew up into be one of their big design centers.
It sounds like it worked.
Yeah,
Go Limerick. That's great. Yeah,
it's a fun little city there.
Okay, and so ADI is a big company. Lots of, I mean, obviously people here probably fans. I was a fan well, I was fans of everything up until they bought Linear Tech, of course. But apparently it's good. I have some people write in, they say it's going fine. So okay. But what segment were you in there?
So I was in the energy metering group. So which is how I got tied into Sense. So when I was I graduated in 2002, which is kind of right when the tech downturn came, and my options coming out of school were limited. I had interned at Analog in their energy metering group, so I had an offer from them, and I had an offer from the CIA, and
Oh, okay.
and Analog was paying a lot more than the CIA was, so
Right. Yep.
I went with that, and so I ended up working in the energy metering IC group that made They were, I think, the original first company to make energy metering ICs. Up until that point, it had all been done electromechanically.
Oh, really? Okay.
So,
I would have
yeah.
expected like discrete op amps too, but
Yeah, it's I don't know. There's at least to my knowledge, there was not a discrete op amp B type of energy metering system out there.
Interesting.
Yeah. So, and this was back in that group was started. The guy that started it was this designer's name's Eric Nestler, who's absolute genius and one of the nicest guys I've ever met in my entire life. He's actually a fellow at ADI now.
Oh yeah, right.
Which is funny because he started this group. I grew it to, I mean, I think it was doing like 40 or 50 million dollars a year or something at one point. And there was creative differences between, and he should have been a fellow long before, but there were differences in the direction they thought they should take the group. He wanted to go simpler because for developing markets like China and India, where the meter manufacturers over there, they didn't want to spend half a penny for an extra cap.
Yeah,
And upper management above him wanted to do like this crazy integrated microprocessor with the metrology stuff and
Yep. The old don't cannibalize your business, right? The NBA playbook right there. Yep.
And there was a falling out, and he left and ended up going to a couple of startups. And one of the startups he was at was this company called Lyric Labs that was doing like probabilistic hardware.
Oh, cool.
And they were using it to do like voice separation and things like that. And he was there, and they ended up getting bought by Analog Devices again. So he ended up right back in the fold, and then they finally smartened up and made him a fellow.
Nice.
But anyway, this guy, nicest guy, and super, super smart, and he kind of started the whole energy metering business at Analog, and probably, I mean, you could probably make a case to say that he started the smart metering worldwide.
Yeah. So could you tell us about? So you said so mostly mechanical in the past. I've seen it before. I think I remember like a rotating disc. Is that the main piece you're talking about? The mechanical? What else? What are you talking about there?
So that's electromechanical, and the disc just rotated proportionally to the power. And it would there was like a little pulse counter that would increment as you used electricity.
So is the disc rotating? Is it like kind of around the main incoming wire, and then it's just using like right hand rule kind of magnetic energy? Is that the idea?
Okay.
Yep. So then pulse counter would be what, like how many steps the disc went past, or like an optical, or
yeah. So so it was like impulses per kilowatt hour, and it's actually the very first smart meters, even though they were electronically measuring the power, there was still like the interface, the utility still didn't know how to use a different interface to it.
Right.
So like the very first ones used a stepper motor driver, and the chip would just output a pulse proportional to the kilowatt hours, and there was you could dial it in so you get so many like pulses per kilowatt hour, and it would just drive a little stepper motor and flip the little rotating number thing.
Yeah, I was gonna say their UI has, for many years, has been sending you a postcard and mark on this postcard where your arrow is pointing, right?
Yep, yeah. Exactly.
That's insane. I mean, I guess I didn't even really think about that. That like, were they dragged kicking and screaming into the smart meter market, or?
Oh yeah,
what?
I mean, utilities don't want to change until they're forced to.
Right.
I mean, it's just so heavily regulated that it's kind of to introduce new technology or new ways of doing things.
Right.
It's one, they don't want to spend money they want to get 10, 15, 20 years out of a meter, so they don't want to replace them, period.
Right.
But
Yep.
two, just to get anything up, because every state has their own regulatory body governing utilities.
Yep.
So it's a huge hassle for them.
Right. Right. And so, okay, so that moved the measurement piece there, but then I was just thinking about, so a former guest was Larry Sears, who was a teacher at my alma mater, Case Western, and he started hexagram, which was the basically the RF piece transmitting. I assume it must have been transmitting, unless that was gas. Oh no, sorry, that was gas meters. So that wasn't even. I was thinking meters, but that was gas meters. So is it to the point now where it's still? Is it still arrows, or what's?
So there's a couple of different ways that they do it. So following the stepper motor, then they went to, and I could be missing a step or two here because being at the end utility wasn't exactly where I was, but then it went to optical infrared, where there would be like a little like IR LED spot right on the meter, and somebody would come to your house and they would have this little tool that they connected up to it, and they could read it optically.
Hopefully a Palm Pilot. I mean, that's what Palm Pilots are good for, right?
Seriously.
IR transmitting of V cards.
And then after that, so now there's they call it machine-to-machine communications.
I've heard of this. This is kind of my job these days. Yep.
Yeah, and it's sub-gigahertz. Like in the US, it's usually the 900 megahertz range.
Okay, all right.
And they'll have a van that drives down the street and just pings all the meters and pulls the info from it.
Nice. Okay, and so it's still just doing the same thing though. They're just driving down the street, picking up how much you've used. It's amazing that there's no actual communication method, just back on a phone line or back on a cell line or Wi-Fi or whatever, right? I mean, it's still person in the field.
That's one of the issues that, like, I mean, not to jump too far ahead with Sense, is that we work off a Wi-Fi, or we transmit data back at Wi-Fi, and the utilities are very hesitant to do that.
They're like, Wi-Fi? I don't understand. What is this?
Yeah, they're like, oh, it's too unreliable for us. We couldn't possibly use Wi-Fi.
Send the message again, guys. Come on. Yeah.
Yep.
Yeah. Okay. So now we're at the point where we've gone from dude knocking on your door and going into your house, and or you filling out a card with the arrows where those are pointing. Boy, I can't even imagine. They must have had people then who got those cards and had to put them into a system, right?
Yeah. Data entry.
Yeah. Wow. You guys are killing tons of jobs. Wow. Jeez, man. You ever thought about that? No. Okay. So when you say smart meters, what else? I mean, is there anything else in there? I mean, or is it literally just measure this thing and do the billing?
So the very first smart meters so I'm obviously using ADI as an example.
Sure. Yeah, we'll just use it as
the very
default.
first one. So we're talking late 90s, early 2000s. It was just called a watt hour meter, and it basically all it did was measure active power.
Okay.
So measure watts and output that pulse. And then subsequent generations started adding additional features. So you could do not only watts, but also VARs and apparent power. And you could get information like frequency and period. You could get power factor information. You can get triggered for certain power events, so like line sag or things like that.
Could you explain what some of those things are?
Yeah. So in power is I mean, you're familiar with this stuff, right? Or at least...
I a little bit, but I'm, like, this is the kind of thing where if me and Dave are talking about it, we're like, oh yeah, kind of like a lot of hand waving, but nobody can see your hands, So
there's, I mean, power is kind of it's a little bit non-intuitive.
Yeah.
And so the power that we all know and love and that does work is active power, right? And it's what we measure in watts. But when your load is not purely resistive, when there's some kind of capacitive or inductive component to it, then you have what's called VAR, it's volt amps reactive, and that's I mean, you for lack of a better term, it's almost like imaginary power. That's power that
Yeah,
gets.
see, I think that's where people always get. That's when I always start seeing people's eyes glaze over, right?
So, and I mean, and what it is it's, I mean, it's power that has to be generated
Yeah.
by the generator.
Right.
It gets delivered to the load, but then it's power that is
Right.
not dissipated. So it actually gets sent back from the load to the generator.
Right. It's like reflected, or it's really just inefficiencies, right?
It
That's,
is. It's
that's
basically
the inefficiency of generating and delivering power.
it's power that needs to be generated but
Right.
doesn't get used. So
Right.
you have to build power plants that can. So it basically increases the power that needs to be generated without being used.
Right. And this is when people talk about load balancing as well, right? Like this is you can have capacitive load or inductive load, right? And you can leading and lagging and all that stuff, right?
Exactly. So normally a purely resistive load has a power factor of 1.
Yep.
And any change in the complex impedance drops that from 1, and that's not good for utilities because they have to generate more power, but they can't bill you for that.
Yeah, right.
They bill off of watt hours. But
Got it.
so
Oh, that's interesting then. So when the reactive power stuff started getting measured, they still don't penalize the user?
yeah, so in most cases, like residential power, you're going to have a power factor close to 1.
Okay.
Because
and that's
you
just
don't-
because of the devices in the house, stuff like that.
Exactly.
You're not running like huge it's not generators, I guess it would be huge motors, right? That would be like a
yeah,
big inductive
the
thing.
place where it gets it is rotating machinery.
Got it.
So motors, things like that, and that's when
So what about like AVE's shop, right? So he's got tons of like motors in his shop. Like a machine shop has tons of motors
Yep.
going.
That's exactly where it would
Right.
be. And what they'll do, usually those loads are inductive, so what they'll do is have a huge bank of capacitors at the site to correct the power factor.
Got it. Okay. And that's so there are different classes of power billing as well, right? Because like an industrial customer would get billed differently than a home customer, just because they expect the industrial customer to have those inductive loads.
Yep, exactly. And it's funny at Analog Devices. I was friendly with one of the facilities guys there, and he was telling me their electric bill, because there's a fab at the Wilmington plant.
Oh,
and
really? Oh, I didn't know
their
that.
electric bill ran between $800 and $1 million a month.
Yeah. Oh yeah. No, I used to be at Samsung, and they would have some serious bills. But they also, I remember this now, they had an agreement too where the power company, if they didn't have uptime, the power company had to pay Samsung, because it would not only would it potentially be loss of money, but also if the power cut in the middle of processing.
You lose all those wafers.
You get exactly, because there's like stuff hanging out up in plasma clouds or whatever, and it just like or there's robots moving something and those smash into the wall, whatever, right? It's just it was a big deal when the power went out. So that's cool though. I didn't realize that ADI had on-site stuff. I remember, oh God, how many years ago was this? 2 or 3 years ago, I was cursing their name for ADI, pushing all their analog processing to TSMC. I thought that was very, very short-sighted. And maybe it wasn't all of it though.
I mean, honestly, most of it is fabulous for sure. They're TSMC, Magnachip. There's a few of them where they fab at. Mostly the stuff that they do in house is proprietary things. So high voltage processes, like really fast stuff. The a lot of the MEM stuff, but that's what they do in house at the fab there.
Got it.
But like analog, like pretty much vanilla CMOS or any of that kind of stuff is all.
Yeah, and it wasn't
fabulous.
that. It was like I think it was because the agreement said that TSMC got to keep all the analog IP around it. But I guess it was the vanilla stuff that you're talking about now. Thinking about it like that, it was probably anything TSMC was doing on their process they kept. So
I mean, it's just too expensive and too difficult to go to like smaller and smaller process nodes. Once you get down, I think they did a 0.18, I believe, at one point themselves. But I mean, after that, it's just you're talking billions of dollars in equipment for each new process node.
Yeah, well, someone's got to do it. I don't know. Yeah. Okay, so so we were at the point where now chips are measuring reactive power.
Yes. So
Yeah. So what changes about it then? So is it just like you start needing to have more measurement line? Obviously, you need to measure current and voltage simultaneously, but you probably were doing that with the active power stuff, right?
yeah. It's more of the signal processing of it. It's
Oh, okay.
it's a little bit
Mathiness.
funky. Yeah, it's definitely mathiness, and one of the ways that they actually had to come up with some clever ways of doing it without like the micro without using a microprocessor to do the math.
Interesting. Okay, so it was using like multipliers or something like that. Like,
Yeah,
like
multipliers. It's
analog
actually
multipliers.
one of the things that you'll see is they call it like filter based metering. So it's all like low pass and high pass and multipliers, and then Hilbert filter, which like phase shift.
Nice.
So when you're measuring reactive power, you basically have to shift the current signal 90 degrees out of phase and multiply it that way.
Mm-hmm.
And one of the ways they do that is it's like a Hilbert filter, which is it's flat for the gain, but it's got a 90-degree phase shift in it.
Yeah. Yep.
But it's there's definitely some funkiness to it for sure, and also not doing like RMS calculations is not trivial in hardware filters, because you have the squaring function and the square root function and things like that.
Yeah, that's crazy. And I mean, I always think about it just with like an analog multiplier, the range you need to have on the output. You know, obviously, if you're multiplying two, nominal analog values, you could quickly, start to scale. Is it log output? I mean, like.
No, it's. Okay. I mean, it's linear.
Okay, cool.
They one of the other things is the inputs too, because there's a range of different current sensing that need to be accounted for your inputs too.
Okay. So why was it just the time frame? Like why didn't they, and maybe it's changed since, but why didn't they push us all into an analog to digital converter and start, doing DSPs or
well, I mean that's really what it is, because the inputs of it's all fixed. It's basically just fixed function DSP. Okay. In the hardware chips, they so the front end, the AFE, the analog front end, it's like you're taking the current and the voltage inputs and directly converting them to bits, and everything is done digitally with fixed function DSP in those chips.
Oh, it is. Okay. All right.
Yep.
Interesting. Yeah, I guess the thing I think about is like, so if I was going to do this, if I was going to try and start measuring power, obviously I'd be very safe. Everybody out there should be very safe. But I'd think I would have a current sense probe, I'd have a voltage probe, and I would look at it on a scope, and I'd want to see the waveforms, right? And then so like in my mind, I'd be like, oh, well, I could like quantize this waveform and then push it to a FPGA or a DSP or something like that. But that sounded expensive as I said it, right? I mean, like, so this is a cost thing as well, right?
Oh, absolutely.
Yeah.
So if you like decap any of these energy metering chips, and by the way, we at Sense we don't use actually an energy metering chip because they don't have the capabilities of what we need. But if you decap them, it's about 1/3 analog and 2/3 digital, which you can see under a microscope, just because of the feature size.
Yeah,
and it's like your voltage comes in on the board. It's basically a voltage divider is all they use for the voltages inputs on that.
Oh, really? Okay.
And for the current, yeah, it's just directly connected and divided down with a couple of resistors. And for the current, there's three main ways that they transduce it. It's either a CT, a current transformer. They use a shunt, but shunts have limited current range because there's one of the regulations is that your energy meter is only allowed to consume so much power, and I mean when you have a shunt, it's just you're dropping. It's like a really
you either have a low signal and low load, or you have high signal and high load, right?
Yeah, exactly. So it's just like a milliohm or micro-ohm like resistor that you're just dumping it over and taking the voltage. Usually, I think those are only they usually only use those up to like 80 amp services. And then the third main way, which is less common, is called the Rogowski coil.
Rogowski, okay.
Yeah, which is I don't know if you're familiar with it. It's
No,
a
no.
it's like a kind of like a CT in that you're generating a field based on the current, but there's no core to it. It's an air core, so you don't have any of the saturation problems that you have with a CT.
Hmm.
The little bit is that it generates a signal that's proportional to the derivative of the current. So
Oh,
you need an integrator. What you need one additional step on it.
so does that like get like additive errors over time? You have to like do like a reset or something?
No, it doesn't. It just adds a slight bit of complexity. And the other thing is where installation matters with a Rogowski coil. So with a CT, as long as your line is just running through the middle of the CT, it's fine. With a Rogowski coil, the if it's not centered, it'll introduce some error onto it.
Oh, okay, okay.
So the installation is a little trickier. And the other thing is, until fairly recently, people didn't manufacture Rogowski coils. You had to, if you wanted to use it, you basically had to roll your own.
Okay.
But
Interesting.
you can buy them now, like off the shelf. But for up, that's only a fairly recent innovation.
Okay. And so what is a what's a common part number that people could look up?
For a Rogowski coil,
No, sorry, of like one of the parts that you worked on or that ADI makes, that because that always helps just to look. People are probably listening and thinking, okay, I can kind of visualize this, but sometimes it's just easier to look at a data sheet.
yes. So God, one of the analog, they're all the ADE lines. So like the very first
Okay.
one back in the early 2000s was called the ADE 7755, and that was
Okay.
your very basic watt hour meter.
Got it.
And then the first three phase we did was called the ADE 7758.
Mm-hmm.
And then I think the last one I worked on was a chip called the ADE 7858.
Okay.
In
Cool.
that group. Let me.
ADE 7858. Yeah.
Yeah.
Yeah, and I'm looking at the 7855 right now. And yeah, it looks, I mean, it's exactly what you're talking about. It's got the PGA programmable front end, and then it's got 2 voltage inputs, one of which was ostensibly for the current like a CT, like you're saying, and then into the multipliers and then DSP stuff. So
Yeah, if you look at
great.
the ADE 7858, that's a little more recent one, even though it's still a few years old now, and that is kind of more where the energy metering ICs stand these days.
Okay. That's cool. And then so people can go and check those out, and obviously ask questions if they have them in the comment section of this episode. But what was after this, right? So you left ADI at some point, and then you went to somewhere else.
Yeah, so I left ADI a couple of years back, and I ended up at Qualcomm,
Okay.
where it was actually a
Before they tried to merge with Broadcom.
yeah, right. It was a small startup that was bought by Qualcomm called Pixtronics,
Okay.
and what they were doing was a a new a MEMS display technology. So as opposed to using transistors to control the light in a pixel, they actually used a little MEMS shutter to
Oh, really? Wow.
for on each pixel. And the cool thing was that for like the same display brightness, it used like half the power of a conventional display.
Interesting. Okay. But obviously, there's all the downside of MEMS versus like of the mechanical aspect of
Yeah,
it, right? So,
which was
yeah.
one of the big issues we were fighting with that was that
Hmm.
you get like we were still it was never released as a product. It
Hmm.
was it was still kind of R&D. We had working stuff, but because it was still R&D, we were in this like really crappy fab and like a
Hmm.
really dirty fab. It was using a process called IGZO, and
Okay.
it's indium, gallium, zinc. I don't even remember.
Zinc.
I
Oh,
don't even remember
wow.
what it.
Oh, zinc oxide? Is that
Yeah,
it? Is
I
it
think
the
it
O?
was zinc oxide.
Yeah.
God, what?
Exo. That's great.
Yeah.
Okay. Yeah, and indium gallium is what's usually those are the big ones in like solar panels,
Yep.
right?
Indium gallium zinc oxide. That's it.
So this is like you were putting like sunscreen onto a solar panel. That sounds what it sounds
Pretty
like.
much. But it was an old fab, and it was just a
Yeah.
very dirty process. So one of the issues we were always dealing with were like particulate matter, jamming the shutters, and things like that.
Uh-huh. Yeah.
And
Yeah.
man, once you work in any kind of display technology, and you start like learning to find all the defects in displays, you can
You can't watch
you
TV
can't
anymore.
watch TV anymore. You
You're
can
like, oh,
always
dead
see them
pixel.
in any
Yeah.
black scenes. You see them. One of the cool things I learned too is that when like all TVs have dead pixels, and they do what's called inking on them, and they basically inject like a little bit of dye into the dead pixel
Wait, just to really blank it out then, or what?
to blank it out. Yeah.
Okay, so there's just natural fallout in the process you're saying, but then
Yep.
they just kind of remove it. It's like what they do when it's like a final QA step or something.
Exactly. They basically map all the pixels in the display, and they go out and ink out all the dead pixels.
Wow.
And the reason they do that, so like a black pixel in a bright white screen is actually really hard to see. A one like white pixel in a dark screen like sticks out like a sore
Yeah,
thumb.
right. Huh. That's crazy. So, and I guess that saves money. That gets their yields up, right? That kind of thing.
Yeah. Oh yeah. Absolutely. Absolutely.
Okay. So, when you did that MEM stuff, I mean, I guess I didn't even ask this about the other stuff. Were you designing the silicon? I mean, what was your role there?
So at Analog, I was a product engineer. So we did all the evaluation and characterization and test development.
So you'd be like the guy who came into an energy company, and you talk to the engineer, and you'd make sure that the product was spec'd out properly, and then actually go and work with the silicon designers to make this new product. Is that kind of the idea?
Yeah, part of it, and then but also like basically running the project.
Yeah,
so
right.
Getting like all scheduling and all the fab stuff, but then designing the evaluation and bench characterization and actually doing that in the lab.
Yep. Data
And
sheet
then-
type stuff, right? Like verifying data
Yeah.
sheets and
Then like failure analysis. So when stuff, especially like preliminary silicon, we would like go through, and when stuff didn't work, get it decapped, and like you with the electron microscope, and find like bad transistors or things that happened. And then when we on some of the stuff, when it was like a simple issue to fix, then we would actually go in and do the design on the transistor level if it was easy. If it was something that like was much more like system propagated, then it would get kicked back to the designers to rework it. But so we did a little bit of silicon design, but that wasn't like the big part of our job there.
that's cool though. I mean,
And then designing all the evaluation boards and the test boards that interfaced with the ATE and
automated test equipment for people that didn't know.
yes, sorry, automated test equipment, all the DUT boards for like final test, and all the evaluation boards and all the reference designs, all that kind of hardware stuff. We did all those designs.
That's a lot of stuff, man. That is a long.
It's
long
kind of
journey.
like the jack of all trades
Yeah.
job at a silicon company.
That sounds fun though. That sounds really fun.
Yeah, it was. I enjoyed it while I was there.
Yeah. Okay. Well, let's talk about where you are now. So you are now at Sense. Could you tell us what Sense is?
Yeah. So Sense is a home energy monitor. It tracks your real time energy usage, and over time, it learns your home, and it shows you what devices are on in your home and how much energy they're using.
Okay. And this is, if people haven't seen it, it's actually really neat. It's nicely designed little, plastic enclosure, right? It's got a little Wi-Fi antenna on it, but you actually stick it in. I was surprised by this. You actually put it into your junction box, right? Your electrical box.
And it gets installed in your electrical panel. You can actually install it outside too. But that's actually a more complicated installation to install it outside than inside.
Why? Because then the probes have to go back into the box. Is kind of the idea.
Well, not that, but you need to install a split phase receptacle outside of it, because we look at both legs of of
Oh.
your power coming in.
Yep.
So you basically need to install like a dryer or oven plug next to your panel if you want to
Right.
install it outside.
Right. So I was talking to a friend about this. We were looking at I was looking at the install instructions, and I was a little. It wasn't dismayed, but I was surprised that like, okay, so the install process, you actually just run some wires into, not dual ganged. What's it called when you have both phases on it for like an oven, right? So an
Yeah.
oven runs on at least, and we're talking about U.S. power here, right? Obviously, Europeans can figure out what the hell they want to do with it, or really anywhere else. But on 120, right, there's dual phase, and you usually have a circuit breaker that goes across both, and so you actually plug into both phases of a two switch.
Yeah, so I mean they're both 120, but they're out of phase. So
Right,
if you
right.
look at both legs together, you can effectively get 240, which is usually what you run your oven off of, or your dryer, or big appliances like that.
Right. So, and you guys want to watch both of them because you want to see the whole thing in the house, and really that's because most residential power is coming in two phase, right? I mean, that's the idea.
Yeah,
Cool.
correct.
So you want to, so that's watching the
It's technically called split phase.
Split phase, sorry.
You'll absolutely the energy nerds out there go crazy when you
so
use
dual
the wrong
phase. It's
terminology.
dual phase. Is that right? No, just really mess with them. Yeah. Okay. Cool. That's good to know though. Split phase.
It's square root of four phase,
Whoa. What is that?
two phase.
Two phase. Got it. So you're monitoring voltage on either of those split phases, and then what? Then you have a current transformer elsewhere.
Yeah, we have so there's it's really simple. You have the two voltage connections to look at both legs, and then you have two current transformers to look at the two currents coming in, and that's it. And the current transformers are just very easy clamp on. You don't have to shut down power to the house or anything. It's just there. You can install it one handed.
Yes, right. Right. No path across the heart, please.
Exactly.
Yeah, okay. So this is an interesting thing because I remember hearing about, people were doing a lot of DIY stuff that they have for a long time. And I remember always thinking about it and thinking, oh, someone wants to monitor the power in their house. That would get so expensive because you need to monitor every branch. If you really wanted to do this, right, you'd have to monitor every branch coming out of your electrical box, going to each, going up to the kitchen or going up to the bathroom, whatever, and thinking, oh, it's like 15 amp service. You'd have to monitor each one individually. And that's obviously not the case here.
No,
So
we do
Yeah.
your entire house from just those couple of connections in your panel.
So what is the missing piece here then? What is the last part that why aren't you monitoring each individual one?
Oh, we don't need to monitor each individual one because we do what's called disaggregation.
Okay.
And we can pick, and that's the special sauce right there.
Yeah.
We can pick out all your individual appliances from just those connections, and it's
Prove
kind of
it.
like it's kind of like pulling like a fire hose of energy and teasing out each individual appliance's usage from that.
Yeah. The way I was thinking about it is if you had 10 people on a phone call and one of them was a crazy Australian like my co-host and you knew his accent, you would be able to say, oh, I can tell when Dave's speaking because of his accent, right? So like how he vocalizes words, there's ways that different devices in your house vocalize their power usage. Is that a good way to think of it?
That's a fantastic analogy, and it's actually even closer than you could possibly even know. It's
Because it's using that's right. Because you guys, let's see, the founders. I was reading the founders were doing something like that, right?
yeah. So the founders, the guy that's our CEO, Mike Phillip. This is the third company he's founded, and the first two were both speech recognition, and it turns out that the problem of energy disaggregation is very similar to speech recognition.
Right. So Joe is saying Mike Phillip is a one-trick pony. You heard it here first. Joe just lost his job. It's crazy.
I think he would agree.
No, that's great. That's if you're gonna have one trick, that's a hell of a trick,
Seriously. And if your trick is applicable in a lot of different
Right.
domains,
Yeah,
then
exactly. That's great. So So, okay, so we were talking a little bit about architecture before as well. So you were saying that ADI does stuff where all that stuff is built in with, fixed DSP, fixed digital signal processing,
Yep.
the filters are in hardware, stuff like that.
Fixed function DSP blocks.
Right. So I assume now that this is more translated from physical things to bits and then throw it into the machine and then you have lots of processing on it. Is that a safe assumption?
Yes, that is the safe assumption. So the issue with the like fixed function DSP method, the your conventional smart meters, whether it's the analog devices or microchip or TI, or they all have variants of the same thing now that it's basically plug and play energy meter. The problem is the bandwidth that those things
Right.
use.
Yep.
So
Yep.
they're somewhere between a 3 and 6 kilohertz bandwidth, and we
You
go
guys
all the
do
way up.
44.1K, huh?
We do up to a megasample a second.
Okay. Great.
So
Great.
in order to do that disaggregation, to be able to see the signatures of all the different appliances, you need that bandwidth. It's the 3 to 6 kilohertz just doesn't give you the resolution that you need to kind of
Right.
do this disaggregation.
Okay. So, well, let's talk about the front. So, obviously, there's a front end here as well. So then, does that significantly change the front end, or is it similar, like just like PGAs and scaling for different? Some
no.
houses are more powerful than others, kind of thing.
No, the front end is pretty much the same. So we do this we divide down the voltage to look at the voltage, and then we use CTs to look at the current.
Okay.
No significant differences. There's a little signal conditioning going into the
Sure.
A to Ds, but
Right.
I
Cleaning
mean,
up
it's nothing.
the buzzy power, right, or the
It's there's nothing earth shattering. Our hardware is just a way to get bits. It's a means to an end. Like I said, the special sauce really is in the software.
Okay. Interesting. And
We're
so,
a software company that just happens to have some hardware.
Right. Yeah. Startups these days are software, but software wrapped in plastic is the phrase that I keep hearing.
Yeah, no, that's a very apt description of us.
Okay. And so, how much of that is happening? So, I mean, obviously, there's different ways that you could do this. How much of that happens directly in the encased piece of plastic, right? So is it like an FPGA in there? Is it a micro? Is it a full Linux box or what?
It's actually a majority of the processing happens at the edge, so in the box.
Okay, great.
We have it's an IMX7.
Okay.
And
Nice.
dual core 1 gigahertz. We run a full Linux box on it.
Nice. Which distro? Or not allowed to say.
We roll our own, actually.
Okay, yeah, that makes sense. I mean, like, so, but you said full Linux too, so it's got like memory management and all that stuff. It's not doing like, it's not like micro Linux or no, that's not the right one. What am I thinking? Like an RTOS. It's actually full.
No,
Linux.
it's not
Right.
not a RTOS. We're not
Right.
strictly real time, but we're very close to real time.
Right. So what I'm hearing here is that you have data scientists and they're like, I need Python on this device. Is that a fair assessment?
Yeah, we have. I mean, data scientist is like the biggest component of our company. I think we have 10 or 12 data scientists right now.
That's cool. Interesting. So how much then does this box need to have regular software updates, like it's connected through Wi-Fi from a company level? You're like, okay, well, we're going from version 1.6 to 1.7, and then you push these big software updates to each box?
Oh yeah, we software update weekly, if not.
Oh, great. Okay.
Like every couple of weeks, but like weekly is standard because basically what happens is we have models for like different appliances, right?
Mm-hmm. Yep.
And when the monitor first gets installed in your house, they have very general models on it. So a very generalized refrigerator model, a very generalized washer model. And once it's installed and it starts observing your electricity, the models start to get tailored to your individual appliances. and so those models get updated fairly regularly. Additionally, when we figure out ways to discover new types of appliances, like we push those models to all the units. So yeah, that it gets updated constantly.
Interesting. Yeah. So I was wondering about that too. So a lot of it, I can imagine that, my brand of fridge has a certain ka-chunk whenever the compressor kicks on, and I get that looks like a certain waveform that's probably pretty unique. But why not just wait until my fridge turns on and then like press a button and like say, oh, my fridge is turned on?
We at the like a couple of years ago, very first, we thought about doing that, and we actually implemented that in a couple of homes, and it was so tedious, and you don't want the end user to have to put that much effort into it, because it's a turnoff to some people, or they do it in an incorrect manner, so then you have bad data, or it's always just better if you can do it on your own. Now we've recently introduced a feature where so there's certain things that look a lot like each other.
Okay.
And to help the learning process, when Sense discovers something that it's not quite sure of, now what it'll do is that it'll give you some options, and it'll say, hey, we think this is either a 1, 2, or 3, and with a certain probability. So we think it could be 50% this, or it might be 30% this, or it might be 20% this one, and allow you to identify it then. Yeah. But so it's kind of like that, but we didn't want to do, because we tried and it just didn't work all that well.
Yep.
Is that, hey, go around, flip this, turn this on. Hey, what is it? Okay, now label it. That's just not.
Right. I kind of think about this like, so this piece of like the classification too. So I use like mint.com just for like tracking finances. And it's like, it sounds kind of like that too, where like I go to, Bubba's car wash, and it doesn't know what Bubba's car wash is. And it tries and it says, you went to Bubbles and Beyond. And no, sorry, man, I didn't go to Bubbles and Beyond, but I can go and fix it. Yeah, and then it kind of learns that and pushes it back to the system. So it sounds kind of like that as well, where you're doing the final 5-10% is human interaction, but it's most of the time, it's going to figure out Chase Bank pulling money out is like my credit card payment, right? So
exactly.
Yeah.
But I mean, in most things we can identify on our own, but there are certain things that kind of look similar to each other, and it just as opposed to getting like incorrect labels on things, that it kind of helps separate that out,
Yeah, of course. So that brings me to my next question. Same question that, family members ask me. They're like, what the hell are you using this for? Right? So why am I actually using mint.com? What are people using this for? Why does anyone need this? Give me the pitch.
Okay, so that's the obvious use case, which is the least interesting, is like energy monitoring and energy efficiency. It's like, we've kind of found that people install Sense, and they're like, oh, this is how much my toaster is using. This is how much whatever, and that shininess wears off after 2 weeks, and it's like, I don't really care that much.
Right. They say it at the first cocktail party, but not the second cocktail party.
Exactly.
Right? Oh, so I'm monitoring my energy now. Look at me.
The more interesting use cases are situations like, hey, you left we send a push notification. Your iron has been on for 3 hours. Did you mean to leave your iron on?
Oh, okay. That's legit. Yeah.
Hey, did I leave my oven on? I can't remember. You look at your phone on the app, and like, no, the oven's off. Okay, good.
Okay. So it's a little bit of FUD, like fear, uncertainty, doubt, safety, kind of like safety and that kind of thing, right?
Yeah. So we could do things like, hey, you're on vacation. Your garage door just opened. You might want to have somebody check that out. Or your sump pumps just started firing. You might want to have somebody check that.
Okay.
Which actually happened to Mike, the CEO. He was away on vacation, and all of a sudden his sump pump started tripping, and he had the water company cut the water to his house, and it turns out his basement had been flooding.
Okay, that's legit. Yeah, that's good.
Yeah, people with a second home that want to keep tabs on it. Or
now we know your target audience, people with money and
But not even that. Like we get users all the time writing in to tell us about things that happen to them. So like one person, I had this like weird water pump issue that the pump was not me, but the user's voice,
Hmm.
and it was costing them like $100 a month. They said they found this and since paid for itself for the first month.
Oh,
Like
nice.
the funniest one that I've heard so far is that there's somebody that was renting their place out on Airbnb,
Uh-huh. Yep.
and they found that they installed Sense, and they noticed after somebody would leave, the cleaning people would come, and then like the TV and the lights and stuff would be on all night, and they were finding that the people cleaning the house were staying over in their
Oh my God.
Airbnb when it wasn't booked for the next day,
Wow.
and they
Okay.
found that through Sentence. They're like, wait, why is the TV on and all?
Okay.
That's the best one I've heard so far.
That's a good one. Yeah, that's kind of creepy actually. Okay. So that's
A little bit, right?
yeah, that is great use cases then. I was thinking it was
Yeah, so
mostly
it's
like, oh, I want to know because okay, it sounds bad, but like power's not that expensive, at least in the States. I mean, yes, you talk to so Dave, obviously he's in Australia, but he pays a lot because him and his wife also pay for green energy credits, which is great, blah blah blah. But like it's expensive there. Like power is rather expensive there, and now they have solar, right? So, but in the States, it's like what? I don't even look at my power bill anymore, right? It's just like obviously I'm also in an apartment, and so I understand that like people with like teenagers running hair dryers and and gadgets and whatever like that's another thing that gets real expensive. But for me, it seems cheap. So that didn't really play into my mind until you said this stuff.
Yeah, like I said, it's like the non-intuitive use cases that are
Yeah.
more interesting. It's like, hey, Sense, how many hours of TV did I watch last week? And send me an alert after I've watched 10 hours of TV. I want to reduce my TV consumption.
Okay, yeah, that's good.
You know?
Yeah, I guess it's one of those things. If you're not measuring it, it doesn't exist, kind of thing, huh? So,
Exactly.
yeah, okay. That's good. That's good. So I mentioned solar. You have a separate version for solar. Why?
Yeah.
Why is that?
So it's not. I mean, it's the same unit. It's just we ship an extra set of CTs with it, and you can monitor your solar usage as well. So you can see
Oh, okay.
how much solar you're generating versus how much of your own solar you're consuming, and compared to how much energy you're using from the grid.
Okay. Cool. Okay, so now it's time for the question for all of our privacy freak out there. Where's all this data going?
It's nowhere. That's one of the big issues that we really wanted to do right. And we have a very clear privacy statement on our website, and we don't do
Okay.
anything with anybody's data without their permission.
Okay. So
To the fact that like nobody inside the company, I can't go look at anybody's data in there. There's
yeah, I get that. It's all
there's
anonymized,
no-
all that stuff. But I guess the main thing is, so I hope you guys are successful forever. But our favorite Internet of Shit Twitter account. What happens if you guys go away? I guess that's the real question. Is it like centralized server? So the app, where does the app talk to? Is it my server? Is it your server? Is it an AWS instance? Like where can I keep it going without you?
Yeah, I mean, I don't actually, as far as the data strategy
Yeah.
goes, that's not something that I like, to be perfectly honest, that
That's okay.
I don't
I
have
mean-
any input on that.
Yeah.
I do know that the guys that are in charge of that are very, very conscious
Oh no!
about
I made Joe
privacy
uncomfortable.
and data. No. I to be honest, I don't have the
Well, here's
the answer that you're
here is a
looking for on
product
that.
suggestion because who doesn't love a unsolicited product suggestion? One thing that you guys promote is no subscription fees. That's great actually. But if you had like a $5 per month, my own private cloud thing, yeah, that'd be interesting as well. So. Just because it is, I mean, it is centralized, right? That is the downside to any so this, you've made a case that this is actually very useful, but it is also controlled by you. So that's the downside, right? Or have like a really expensive version where it gets served up directly from the device onto my Wi-Fi network, right? Because all this stuff. So like, what happens so this is going back to a server somewhere, and then it gets pushed down to an app, right? So there's no way to do local like the sense is on my Wi-Fi network, my phone connects to my Wi-Fi network, it talks to, a local IP. There's nothing like that, right?
Yeah, no, there's too much like processing that needs to go on. So
Oh, okay. Okay.
a lot of the processing happens on board, but then you need to all the data needs to be stored, and
Yeah, right.
and it's a lot of data. So
Yeah.
we can handle if your Wi-Fi goes out, we have enough memory on board where we can capture about 8 hours worth of energy usage before data starts getting lost.
Really? Oh, interesting. Okay, so that's still pretty raw though. So
Yeah, so if your like Wi-Fi goes out or something happens to your cable connection, we can continue to capture about 8 hours worth of your usage before we start to lose stuff.
Okay, yeah, and so this kind of goes back to the edge processing that you mentioned. So I actually didn't know this term until a couple months ago. When you say edge processing, what do you mean by that?
So that means we're doing we're not taking raw data and throwing it up to the cloud and processing in the cloud. The most of the processing happens in the box, and we are sending basically what we call events up to the cloud. So the processing on the monitor looks for events, and then we send those events up to the cloud.
Got it. And then that does the aggregation and all that stuff of
But all the models, all the machine learning, all that, the neural nets and stuff, those are running on the monitor.
Right. Yeah, I kind of think about it kind of like a stochastic, the looking at like how close to a certain shape it is. Is that kind of a good way to think about it? So if a compressor on a fridge looks like a spike and then like a trail off, you look for a spike and a trail off and you say, yeah, this is like 70% likely that this is a spike and a trail off.
Yeah, so I mean, we look at things both in the time domain and in the frequency domain.
Oh, cool. Okay.
So we look at, so for example, like a heater, like something with a compressor and then a fan, or whatever. We could see, okay, the compressor comes on and then 10 seconds later a fan comes on. When the compressor comes on, there's this big of an inrush current. It averages this much wattage, and so like all those factors together, like the power, the duration, and the order in which things happens, those help us kind of get a fingerprint of it. On top of that, we also look frequency domain. So what kind of like this is at a 20 kilohertz, this is at a 30 kilohertz, this blip, and we do use like to kind of look at like frequency information over time for different things.
Cool. Oh, that's great. Is that all done? Is that FFT done internally or in hardware or in software?
No, it's done in software.
Okay. And so what about, I guess this also kind of comes back to the other question I was going to get to. How do you power this thing? Is it just drawing off those power?
We just are connected to the line, and we pull right from there.
Okay. And then you just internally do like a module, like 120 to 5 volts or something like that?
So it's funny, I actually did the design on that. It's just a isolated flyback.
Okay. Oh, great. Yeah. So I've seen ones with like the modules recently, because like modules for me, they're so simple, and to be honest, I'm still scared of AC wall power. I probably shouldn't be, but I still am. And so
the problem with modules is, one, they're expensive, and two, their footprint is just too big. We're space constrained with like being able to fit in the panel with, like, I mean, I'm sure you've seen some pictures of people's panels with like wires everywhere. There's not a ton of space for things and stuff like that. So it's to both price and air footprint area.
Got it.
We just have our own flyback.
That's great. Yeah. So I guess that kind of comes to another question: is what about are there regulations for being in a power box, like NEC, like National Electric Code?
There are, and we follow them all. So
what I don't actually know any of these things. So
I mean, do you have about 15 hours? It's
welcome to the Amp Hour After Dark.
Seriously, right?
Co-hosted with Joe. You start playing some jazz in the background.
Nothing more exciting than 1 a.m. NEC discussions.
Yeah. Wow. But so what is it like?
So I mean, it has to do with like sizes of conductors in the raceway and what kind of CTs you can use and double insulation and all these kind of things. So not only do we have to deal with the NEC, but we also have to deal with like UL rules, and we have to deal with FCC rules, and we have to deal with like CE. So we're like threading all those needles because we're I mean we intend to sell into Europe and not just
Yeah.
North America. So we make sure we comply. So not only do we do the FCC, but we also meet the CISPR rules too for emissions and
Got it.
because we were on just laying all that groundwork.
And are you selling into Europe yet or no?
We are not selling in Europe yet. We actually just started shipping to Canada,
Woot.
and we have some trials going on worldwide right now, some pilots. So
Uh-huh. So what changes? I guess I don't even know. Like I kind of alluded to this at the beginning. I don't even know though what their power boxes look like. Are they different? Are they much different or no?
So one of the big things is like whether they're meant to be installed indoors or outdoors.
Oh,
But
interesting.
there's also like different countries and different regions have different like standards for panel design and things like that. So it's yeah, it gets a little bit complicated trying to, like I said, trying to thread that needle. So you have to make so you can use one design to meet all the standards.
Yeah, I was gonna
Which
say.
you don't want to be having like a million different SKUs because that just
Right.
becomes obnoxious to manage.
How many times have you cursed the initial plastics designer? You're like, if I just had two more square inches, it'd be so much easier.
Yeah, what's funny is that that Bolt did helped us do some of the
Oh, yeah?
initial plastics
Nice.
design. Yeah.
Okay, yeah, we love Bolt around here. That's great. Yeah, they. So wait, would you guys come out of the Bolt accelerator?
So no, so Bolt actually invested some money. We never were part of their accelerator, but they invested some money in us in our seed round.
Okay, that's great. Yeah, and then invested some time too. Apparently, I mean, it's
Yeah.
it's a nice design. It looks friendly. I think that's really important as well.
Yeah, there's a couple of issues with it, but overall it's pretty good.
Yeah. I mean, yeah, of
Like
course.
anything.
It's the design, right? Yeah. And it's small. That's the main thing, right? I mean, I don't know if so you said there's a lot of stuff going on in most electrical boxes, but like, does it need to be that small? I mean, like, are there times where people are like, oh yeah, this just
Oh yeah,
barely
no, there's
fits?
definitely there's a lot there is sometimes when things just barely fit. One of the issues that we're having at a certain amount of installations in California
Mm-hmm.
uses a bus bar, and our CTs, like some of the just barely fit onto some of the bus bars.
Oh, interesting.
And so what happens is if it's not closed all the way, that like causes some signal issues if the clamp isn't closed
Right.
completely.
Loops like being loops, right?
Exactly.
Yeah.
Yep.
Oh wow. Okay. Yeah. Yeah. I guess then you would have. There's all these standards of different boxes, whatever, right? So.
Yeah, but some like boxes are much tighter. Like a box in an apartment is generally going to be smaller than something on your house. And and if the electrician that wired it did it do a great job or was it careful? Like there's like wires everywhere, and so trying to cram something in there, or if the box is very shallow, then what can happen is once the CTs are connected, when you close the door, it kind of presses on the CT and causes them to open a little bit. So
Yep.
yeah, there are certain areas where it's space constrained. So the smaller we can make this, the better.
Got it. Yeah, that's interesting. What about the install? Is it like so? If like my grandmother wanted to install one, would she install it?
So by law, we have to say an electrician should do it.
Got it.
But
Okay.
it's very simple, and anecdotally,
Yes.
I think a very good portion of our customers have installed it themselves.
Yeah. I mean, I've installed breakers myself, right? So I probably would feel comfortable enough doing it myself.
Yes, I mean if you've installed a breaker, I would feel comfortable, I think, installing this. But again, electrician has to do it according to our Intertech UL
Sure.
certs.
No, that makes sense. And I guess the main thing is, so you're not going to shut off power from the street, right? But you will probably turn off the main breaker, like the 100 amp or service, whatever 200 amp service you have, and you'd be pretty much safe at that point, right?
Oh yeah, but I mean it's meant to be installed without doing that.
Oh, really?
But you can. I mean, yes, you can turn off the main breaker.
I'm neurotic. Yeah.
No, most people, especially if you don't work with electricity on a daily basis, it's definitely an area where it's better to be safe than sorry, especially if you're not comfortable with it, and a lot of people aren't. So, it's not worth shutting power down to your house for 5 minutes is probably safer than if you're not comfortable with that kind of stuff.
Yeah. Yep. Definitely. Interesting. Okay. So, I guess that was the question I was going to ask. Is the so in the 240 case, do those power boxes like in Canada or elsewhere? Well, Canada's not 240.
Nope, Canada's not.
But when you guys switch to 240, will it just be single voltage input, or will you actually need to have two measurements of voltage? Like, is there split phase?
It depends. So some places have two sides of 240. Some, it's amazing how unstandardized across the world it is.
Yeah, I've looked at that map before too, where like there's like a Wikipedia map where there's all the colors, but then they also have like the slashes of lines too for like, oh, this one's 50, this one's 60. Some countries do, but like Brazil does too, right? And Japan does too, and it's like, what was happening here?
Yeah, but so the model, we just finished or just released a new design, and so this one we just released to manufacturing, and this can handle 120 to 240, 50 to 60. So this can be installed anywhere in the world and handle all those different situations.
That's awesome. Wow. Okay, I like it. So what else should people know about this thing? I mean, we're starting to kind of run up on our time here, but what are you excited about for power mounting for the future? I mean, where do you see it all going?
I think eventually,
I think we reached the peak. We're all good. Yeah, just keep buying
our
cents.
capabilities are. I mean, it's going to be integrated directly into either your panel or into your electric meter. I mean, that's where it's headed.
No, cool.
So one of the things is right now, like utilities, they need to build generating plants that can handle peak load.
Right.
But right now you might hit peak load a couple times, handful of times, like mid-August, everybody comes home from work and turns on their air conditioning. They're hitting peak load, right? But the power plants need to be designed for that, but they're never using
right.
that.
A lot of excess capacity just for that one event, right?
Exactly. Yep. So one of the things that would be interesting is if and the other thing is nobody wants to engage with your utility. You don't care who your utility is, and
yeah, it's not like a nice brand that you're like, oh, I feel so warm and fuzzy about them.
Yeah, right. Nobody cares about
awesome
National Grid.
Right. PG&E.
And they have no user or customer like visibility into how their customers are using energy or anything like that. So one of the interesting things could be where where your power company incentivizes you to, hey, you know what? If in the middle of August you come home, if you turn your thermostat up a couple of degrees, we'll takes 5 cents a kilowatt hour off your bill this month, or hey, if you run your dishwasher 3 hours later, we'll take a quarter off your electricity bill. So
I've heard that one for a long time too, and it feels like it's not enough of an incentive. I'm sure that it is, right? But it feels like it's like,
oh yeah, no, that's the thing. It's you're right. You're completely right in that energy is cheap. So
so what we should do is raise energy prices, and then all the utilities go wild. It's a touchy issue, I'm sure, and especially because I think the real thing is that, and what your product kind of touches on too, is that like I don't think about power until something's wrong, right? And then you really notice it, right? I mean, obviously the whole Puerto Rico thing, there's people that are still hurting down there.
Yeah, they've been months without
power. It's obviously it's very front and center for them, and it's there's other people in other parts of the world where it's a very big deal, but like at this point, most people are sitting around, not most people, probably most people listening at least, are very lucky to have, reliable power that you don't think about it. And so it's interesting because this kind of plays on the whole convenience factor as well.
Yeah. I mean, it does. And it's like the big, I guess, like this advantage that Sense gives you. It kind of lets you know what's going on with your house, right? It's like, it's not so much, although it's an important fact, it's not how much energy I'm using. It's, hey, did I leave my iron on, or did the kids get home from school? Oh yeah, I see the toaster went on, the microwave went on, the bathroom lights went on, or whatever. we can kind of make add a little bit of intelligence to dumb appliances. Pretty much is kind of
Right.
how you could say it, and the more people that use it, like we heavily take advantage of the network effect in that the more people that use it, the better our models get, which makes us that much more useful, which makes more people want to use it, and like I said, it's those non-intuitive use cases that are the most interesting, and who knows what else we'll discover as far as ways that can be used.
So you guys should do like a joint promotion with Amazon Key, right? So yes, the Amazon delivery driver, you saw him get into your house, but yes, he's also still watching TV in your house.
Oh my God, you couldn't pay me enough to use Amazon Key.
I'm sure that some people have the similar reaction to Sense, to be honest, but yeah, the Key that one is I very uncomfortable myself. So
which is fair. I mean,
right. It's a convenience. It's really is. It's convenience versus security versus anything else, right? These are the trade-offs. Some people are going to make them, some people aren't, and that's fine. But it sounds like there's some significant conveniences from Sense.
Yeah, I mean there are, and it's like you're absolutely correct. Is it a trade-off, and I so far we found most people, our customers have been, that's the trade-off they've been willing to make. I think it's much less invasive than a lot of other stuff out there,
Totally, yeah.
especially for the benefits that people have had from using it. But
Right.
I mean, that's a decision left up to your mileage may vary, right? Like,
Sure. Well, and I think the non-contact piece of it, right? That's what's really interesting. You're not controlling light bulbs, but you're at least telling when they're on. And so it's like I think you guys talk about smart home a lot, but it's I think in your you have smart home all over your site, but really it's like smart home by proxy, right? You're not like actively controlling things and putting things like last week or 2 weeks ago we were talking about there was a light socket that was controlled, right? And then you installed that thing. It's like, oh well, that's very invasive.
I mean, on our roadmap, I think eventually we'd like to allow the users to be able to have some control and integrate with that. But as of right now, it's like I said, we're adding a little bit of intelligence to dumb appliances, so you can kind of figure out what's going on.
Right, and it's going to happen at an API level versus direct, like your electrical box talking to a socket, right, or having a relay at the electrical box. So yeah, cool.
But yeah, it's an interesting space.
Yeah, no, this is great, man. So I appreciate you telling us all about it. I expect there will be other questions down in the comment section. Where can people find you though online if they have direct questions?
I like how we came across each other. Twitter is usually a good one, and I'm at the Joe Bamberg.
The Joe Bamberg, the one and only.
The one and only.
Yeah. Cool.
I think is probably the best way to get a hold of me.
Okay, great. Well, we will definitely post that. We'll post links to all of the Sense pages and stuff like that, and some of the data sheets that you talked about. So, Joe, thanks for being on, and we look forward to talking to you more about power in the future.
Thanks for having me. This has been fun.
All right, talk to you soon.
Okay, take care.